Mercado math, it's time to do some math. Let's Merca do it. Real quick video, guys. Special cases for a system of equations. One solution, no solution, infinite solutions. Very similar to what you did when you solved equations. And to be honest, when you're solving them, it's going to be the same way you know. One solution is when you solve an equation, you will get something like x equals 3. That means that only has the solution at x equals 3. At that point, that's where they intersect. When x equals 3, that's where they meet. No solution, you'll get something that looks like this. 3 equals 5. It makes no sense. It makes no sense because it has no solution. And infinite solutions, you'll get something that looks like this. 3 equals 3. If you remember when you solved it for an equation, it was all real numbers. For a system, it would be infinite solutions. There is that difference. If you did inequalities, hopefully you start realizing the difference between infinite and all. But we'll talk a little more about that in a moment. So to show you what one solution looks like, well, when you graph two lines, they intersect in one point. Meaning, one solution, they intersect in exactly one spot. Just like that. That's it. That's the only solution. That's the only point on both lines. And once again, that's what you're finding. The point on the lines that they both have. No solution. The lines are parallel. There are no points of intersection. They will never have a point where they touch. There is no point that you can find that would be on this line and this line. Here, there's that one point. This one point is on both this line and that line. If we call it A and B. This is the only point that's on A and B. Here, there's no such point that can be on both A and B. Now, infinite solutions, we're going to draw two lines. This is the weird one, but it does make sense. There's my first line. We'll call that A. And I'm going to draw my second line in blue. And the second line is literally on top of it. There's my B line. That is what infinite solutions looks like. It's when you have two lines, but they happen to be the same one. And there are infinite points. If I draw a point on here, this point is both on the A and B line. It's on both lines. This point is on A and B. This point is on A and B. It has infinite points on both lines. Every point on here is on both A and B. So it has infinite solutions. Is that all of them? No, because if I draw this point, that's not a solution. It's not on either of them. And on a graph, remember, on a graph, you will have a line. You can have another line. So there'll be infinite points of intersection. That is not all of the points of the graph. 0, 0 is not on these points. So there's a lot of points not on there. There's infinite points on it, but there's infinite points not on it. Okay? That is I should have just attached this to the last video. But that's it. Those are special cases. You solve your system the way we've been doing. You do your substitution, elimination. You solve it. If you get something like this, that means one solution. If you get something like that, no solution. If you get something like this, it's the same solution. Okay? Yeah. Short video, I'll still do a pun. Now, if you've been watching these videos and you've been sticking it out, I'm hoping you enjoyed a little bit. But I want you to know, I think you guys have been doing a super job. Super job.